Okay, so today we are going to be talking about factors, division. There's two kinds of division and how it all works together. So before we do it with like algebra stuff, I want to let's just review with some basic math. Okay, so first of all, some vocabulary. Okay, so we have, let's say that I have 36 and I'm going to divide this by 2. Okay, so do you remember how this long division, we're going to do basic long division. So you ask yourself, 2 goes into 3, how many times? 1. 1 times 2 is 2, then you subtract. Then you bring down the next number. 2 goes into 16, how many times? 8. 8 times 16, 6, 0. Okay, so that's a long division problem. Well, what does each one of those things mean? So one of the things it means is that 2 and 18 are factors of 36, right? So division shows us factors. By doing division, you can get the factors. So division shows us factors. That's one thing that you need to remember. The next thing, when the remainder is 0, that's when we know it's a factor. So the remainder is 0, so we know that 2 is a factor of 36. Okay, remember remainders? So, and this is in algebra, we call this the remainder theorem, but let's do 36 and let's divide it by 5. Okay, so 5 doesn't go into 3, 5 goes into 36 7 times. 7 times 5 is 35, remainder 1. So is 5 a factor of 36? Is 5 a factor of 36? No. Why? Because the remainder is 1 and not 0. Okay, so I'm going to leave that there for a second. So once again, division helps us find factors. We can do division to show us the factors of a number. If there is a remainder that's not 0, if there's a remainder other than 0, then it is not a factor. If the remainder is 0, it is a factor. So here, remainder was 0, yes, it's a factor. Here, the remainder was 1, no, not a factor. Okay, so that's just reviewing with basic numbers. Now we're going to do that with polynomial functions. Fun time! Okay, so I'm going to do several examples of each one of these, and then I'm going to have Ms. Clark put the subchapter worksheet on the board, and y'all can start going through the subchapter together. Okay, so I'm going to do some examples, and then we're going to go through the subchapter. Now, the first set of examples are dividing by a single term. So if I have, let's see, 18r squared minus 12r plus 6. This is number 4, by the way, and I'm not sure. I'm not sure what this is. 6.1.4 maybe. And I want to divide this by negative 6r. Okay, so this is a single term. So I'm just going to divide each one by negative 6r. Okay, so let's see, I end up with 18 divided by negative 3 is, I'm sorry, 18 divided by negative 6 is negative 3. R squared divided by r is just r. Okay, negative 12 divided by negative 6 is positive 2. R divided by r is cancel. And then over here, I can simplify the 6 and the negative 6. So it would be minus 1 over r. Okay? So this is division by a single term, by a monomial. So this is division by a monomial. And when it's a division by a monomial, we just do each one separate, each term separate. Where it gets tricky is when we divide by a polynomial, which is where we're headed to next. And we are going to do this using long division first. Okay, so we're going to do number 24. 3p to the third minus 2p squared minus 4 divided by p minus 2. Okay, you're going to set it up just like a long division problem from when you first learned long division. Now, okay, this right here, let's talk about that for a second. You have to have a placeholder for every power, for every exponent. Okay, so this one has p to the third, p squared. It did not have a p term, but that doesn't mean I can't have a p term in my answer. It's kind of like if I was dividing 10 by 1104. See how I put a 0 here? Because there's nothing in the tens place, but we still have to have a placeholder, right? So that's what you were doing. You were just holding the place. You didn't even maybe know it. So that's what I'm doing here. I'm holding the place of the p term because there could be that term in my answer, even though there's not that term in the question. Okay, so we are going to do the same thing we did in long division when it was just numbers. We're going to ask the same questions. We're going to do the same steps. So we ask ourselves, p goes into 3p to the third how many times? Or you can say p times what equals 3p to the third. Okay, well, it's 3p squared. So I'm going to put 3p squared. Now, you want to keep your powers lined up. So do you see how I have a 2, a squared, and a squared? So you always keep them in line. Okay, so what's the next step? You ask yourself the question. Next step, so ask yourself the question. Next, we multiply. Okay, 3p squared times p is 3p to the third. 3p squared times negative 2 is negative 6p squared. Then we subtract. Okay, so negative minus a negative makes this one positive, so 4p squared. Then we bring down. Next term. Okay, and then we ask the question again. So p times what equals 4p squared? Well, it's 4p. Okay, so then we multiply. 4p times p is, oops, I forgot to actually bring down the next term. 4p times p is 4p squared. 4p times negative 2 is negative 8p. Then we subtract. So we multiply, then we subtract. Okay, so this cancels. Negative negative makes this 8p. Bring down the next number. And then I'm just going to write repeat because we just keep repeating the same steps. So p times what is 8p? 8. 8 times p is 8p. 8 times negative 2 is negative 16. We subtract. 4 minus negative 16 is 12. So we have a remainder plus 12 over p minus 2. Okay, so it's over what we divided by. Okay, so here's my answer. So and this is actually 2 lessons later, but it's the same idea. Is p minus 2 a factor of this polynomial? No, not a factor, because I had a remainder. So you can always divide, right? It's just you're not always going to have, it's not always going to be a factor. It's not always going to be a remainder of 0. Okay, shall we do another one? Okay. Let's see, where is it? Okay, here we go. We are going to do this one. 4k to the third minus 2k minus 8 divided by k plus 1. Okay, so k plus 1, 4k to the third minus, or first what am I going to put? 0k squared minus 2k minus 8. So do you see what I did there? Remember, I had to hold place. Okay, so we ask ourselves, k times what is 4k to the third? And our answer is 4k squared. So make sure you line up your exponents. Then we multiply. So 4k to the third plus 4k squared. Then we subtract. Then we bring down the next term. Okay, so k times what is negative 4k squared? And that's negative 4k. So negative multiply. Negative 4 times 1 is negative 4. Then we subtract. So negative 2 minus negative 4, that's plus. Okay, and those guys, it doesn't hurt to put that in your calculator, just to help you out. Just negative 2 minus negative 4, just to make, because like, why would you do all of this work and understand long division, which is hard, and then get it wrong because you did that too fast in your head? So put it in your calculator. Don't double check it. Bring down the next term. And so k times what is 2k? And the answer is 2. So that's 2k plus 2. Subtract. Negative 8 minus 2 is negative 10. So plus negative 10 over k plus 1. Okay? So that is long division. Now, there is another way of doing division, and it is called synthetic division. And synthetic division just uses, well, we're going to just do one. It uses, to me, a lot less room, and it's a lot easier to do. Okay, so this is, let's see, number 2 from your homework. So x to the 4th minus 5x plus 10 divided by x plus 3. Okay, so in synthetic division, we set it up like this. Okay, and right here, we first set this equal to, like what we're dividing by, set it equal to 0. So x plus 3 equals 0, so x is negative 3. So right here I put negative 3. Okay, then you put all the coefficients in a row. So what's the coefficient here? A 1. Now, what's the coefficient for x to the third? Say it out loud. What's the coefficient for x to the third? If you said 0, you're a winner. What's the coefficient for x squared? Also 0. Then negative 5, and then 10. Okay, so you have to put all the coefficients. If any are missing, you put a 0. Coefficient. Okay, so the steps are, we bring down the first number, and then after that, it's just a game of multiply, add, multiply, add, multiply, add. Okay, so negative 3 times 1 is negative 3. Add negative 3. Negative 3 times negative 3 is 9. Add 9. Negative 3 times 9 is negative 27. Add negative 32. Negative 3 times negative 32 is 96. Add, and I get 106. Is that right? Okay, this last one is the remainder. So whatever you get there is the remainder. So the way you write your answer is these are the new coefficients. New coefficients. I don't think I spelled that one right. And you step down 1 power. Okay, so my question was a fourth power, so my answer is going to start with a third power. And then these are just minus 3x squared plus 9x minus 32 plus 106 over x plus 3, my original divisor. Okay, so we'll do another one. Y'all can watch this one again if you want, but I start by listing all the coefficients. Once I bring down the first number, my steps are multiply and add. So I'm just multiplying, add, multiply, add, multiply, add. Then my answer, these are the coefficients for my answer, and I start by stepping down 1 power. So make sure you've written all this down. Okay, so let's do another. Pause if y'all need to write that all down. Let's do another one. Okay. Okay, so this one is written a little bit differently. P of x equals 2x to the third minus 9x squared plus 27, and we want to use synthetic substitution to evaluate x equals 2. Okay, so when x equals 2, that's already the factor has already been set equal to 0, so I just put a 2 right here. Then I put my coefficients. So 2, negative 9, 0, because there is no, and then 27. Okay, so remember I had to put a 0 because there is no x term here. So now I'm going to follow my steps. Bring down the first one, and then multiply, add, multiply, add, multiply, add. So 2 times 2 is 4, added to negative 9 is negative 5. 2 times negative 5 is negative 10. Add that, negative 10. 2 times negative 10 is negative 20. Add that, and I get 7. So my answer would be 2x squared, remember because we stepped down 1, minus 5x minus 10 plus 7 over x minus 2. But what this was asking is it said evaluate for x equals 2. So here's a little just interesting trivia. If I were to plug 7 in here and have a 7, I mean not 7, sorry, 2, if I were to put a 2 in here and evaluate with 2, I would get 7. So the ordered pair would be 2, 7. Does that make sense? So it's the same as plugging it in. It's the same idea. So 2 things I can do here. I can divide by 2 or divide by the factor x minus 2 and get this answer, or I can evaluate for x being 2 and get the answer of 7, meaning that if I plugged a 2 in for x here and here, and so it did 2 times 2 to the third minus 9 times 2 squared plus 27, I would get 7. Okay. So I've done some synthetic division. I've done long division. The last section talks about finding the roots. So let's see. Let's do this one. This is number 5. And this is like 6.2.1, I think. 2x to the third minus 12x squared equals 32x minus 192. Oh, this is something I didn't say, but for both long division and synthetic division, you need all of the terms on the same side and you need them in descending order. So kind of what we talked about last week, standard form. So you want to put them all in descending order on the same side of the equal sign. So let's do that first on this one. 2x to the third minus 12x squared minus 32x plus 192 equals 0. So I just moved those over to the other side. Okay, so there's a whole lot of ways that I can find the roots to this problem. I can do some factoring, I can do long division, I can do all kind of stuff. But first, quickly I realize these all have a 2 in common. So I'm going to factor out a 2. So then I'm left with this. Okay, and do you remember 2 weeks ago when we did split the middle? Or not split the middle, factor by grouping. We are going to factor these by grouping. So I'm going to group these and those. Remember, I had to put a plus sign in between because I left the negative with the 16. Okay, so this first one, so I have 2. I can't forget that 2 out there. And then I have, these both have an x squared in common. So I'm left with x minus 6. These are both divisible by 16 because 96 divided by 16 is 6. So I'm going to factor out a negative 16 and I'm left with x minus 6. So remember, then we undistribute those. So I still have my 2. Now I have x squared minus 16 and x minus 6. Okay, now this one is the difference of 2 squares. I think we talked about that a few weeks ago. So it's x plus 4, x minus 4, x minus 6. Okay, so this is all the way factored. Now, to find the roots, we set each one equal to 0. Okay, so x minus 4 equals 0, x plus 4 equals 0, x minus 4 equals 0, x minus 6 equals 0. So x equals negative 4, x equals 4, and x equals 6. These are the roots or the zeros. Okay, this is where it will cross the x-axis. Does zeros have an ES? I never know if it's like heroes where you add the ES. I'm going to say yes. Mr. Stortz, of course, will know the answer, so we can double check with him. So this would cross the x-axis at negative 4, at 4, and at 6. And so those are the roots. So these are the roots. These are the factors. Okay, so there's these factors. If I set them equal to 0, then they become the roots, or the zeros, or the solutions, or the x-intercepts. Okay, so there's a lot of meaty stuff here. Synthetic division and long division can be super fun. The idea of factors and roots and remainders, that vocabulary should be a reminder of things you did when you were younger. Now we're just putting it in a new context. You're like, yes, new context for my awesome vocabulary. I think that's it. Yeah. So what I want y'all to do is do whatever the 6.1 subchapter. I think there's 2 parts. But if y'all want to start that together, you can even skip to the long division and the synthetic division problems so that you can make sure that y'all get a lot of them done. Y'all should still have like 20 minutes left in class, maybe 25. So y'all should be able to get a lot of problems done. Ms. Clark, if you'll put it on the board, and then, you know, there's the answers. So if y'all want to check your work, that would be great. Next week, happy Thanksgiving. The following week, we finish up chapter 6. Woo! I think there's the practice test and the test, and then we start chapter 7 before we do the midterm. So hope everyone has a great day, and I will talk to you guys later. Bye.